There's a few things on that 3/8 plasma cut plate that I just don't really trust. And I really don't want to send it off to the laser cutter and get bit in the ass. So I'm going to make another one. I picked just a scrap piece of 1/4 inch. And so I've got everything clamped down and lined up now. And I'm not using a center drill. I'm using just a stubby. Mainly because I can't get the round column down any further. I had everything clamped and then realized that I should have clamped some 1, 2, 3 blocks up underneath to get the extra height. But other than, doing the starter holes, everything else fits. Everything else, the drills and stuff like that, they're all okay. So, biggest pain in the butt is going to be the big center hole. Okay. I'll decide later exactly how I want to do that, whether I'm going to rotary table it or just hole saw it. Most likely I'll just hole saw it. I went ahead and clamped the paper down here just so I can get a reference. So basically now I can just get close, zero out the DROs, and then everything will be set up from the DROs from that point. So that point could vary. It could wander this way at least 1/8 of an inch. I've got a 1/4 inch of clearance here. I don't have a great deal over here. But anywhere within 50 thou ought to be just fine. So. Alright, that's close enough. Let's pick 70. Alright. So I'm going to go ahead and drill this hole, and then I'll move around to the other holes, and I'll put a 1/4 inch pilot in each of those. And if you're wondering about these wandering, I wanted to line the paper up to the edge too. So what I did was I pushed them forward hard and lined them up, and that should have it fairly parallel. So I could have torn the paper out of the way, but if it tears out of the way, fine. If not, I don't care. It's just kind of a visual double check. It just dawned on me though that it's a good thing the paper didn't rip up completely. Because something I did want to do is get this inside curve. I don't care a whole great deal about the curves on the outside and that stuff, but I did want to get this curve drawn on here, because I'll have to bandsaw cut that close and then use the belt grinder to get the rest of it. All the holes are drilled. I'm ready to pull it out of here. Oh, no, not ready to pull it out. I'm ready to increase the size of all the holes. Well, I'm getting ready. I've got the table locked down. Got the new 3-inch hole saw. I've got the pilot drill just barely sticking out of there, enough to register in this hole. I've already checked that. Everything's fine. I may need, since I've only got a 1/4 inch plate underneath here, I may need to put that up more before I'm done actually cutting. But I wanted to show this one. I bought the new one. Let's see if it'll... I know it'll focus this close. Let's see... give it a second here. See if we can even get it readable. There we go. It's coming in. Mild steel, 115 RPMs. This is the first time I've ever noticed it on any of the hole saws I've bought. That it actually had a speed on it, a recommended speed. So that's as slow as my as the round column will go, is 120. Then it jumps to 200. So I'd probably be fine with 200, but I'm going to start at the lowest. If I have too much belt slippage because of the tiny pulley it's on, then I'll worry about it. Let's see what it does. Oh, and I'm putting earmuffs on for this. I don't wear hearing protection a whole lot in the shop, but my past experience with these things is they screech extremely loud. So most likely I'll turn it all down on the video, but I'm only a third of the way in, maybe quarter. What I want to do though is put that pilot hole drill the rest of the way back up, because I definitely don't want to go all the way through the aluminum and scar the. If that was a little more solid, it probably wouldn't squeal quite so bad. But anyway, so I put that up in there, so it's out of the way. Don't have to worry about it. And I started with the pilot hole because I really didn't want it to wander much there. A lot of times, of course, a lot of times I run it at a higher RPM and it wobbles around. This is getting a nice clean cut here. So now that there's enough groove there, I don't need to be. It'll self-align. You know, it'll stay in that hole. I don't need the pilot drill anymore. That's about as tight as I can get it. Oh, okay, that's loose now. Let's Any wonder why the bearings of the motor are going out? Yeah, still the same. All right. Well, let's see if it slips. It's a little better. Let's try the... Oh, man, that takes quite a bit. Well, it's better, but... Yay! Okay, that's my hole. The rest of it I can drill with the rest of it I can drill on the drill press, and then worry about cutting out the outside. Left a couple of burrs as expected, but shouldn't be any big deal to just use the draw knife deburring tool, basically. Nice. All right, let's see if I can go around here and get a little bit better line for what I'm trying to get to. So I want to trace over the black one and then cut to the inside edge. Or grind to the inside edge. Might have been better to do it the other way. That way I could see when I got up to the edge. But and that is going to be basically done like that. So that gets me close enough for what I'm doing. That line there really doesn't matter a great deal for what I'm trying to test. This is the only one I can't scribe in real easy, so the this is why I did it at a 1/4 inch, because now when I go to the bandsaw, 1/4 inch will cut a whole lot easier than 3/8. Actually, had I thought about it, I probably should have had them plasma cut in 1/4 inch. Might have come out more accurate. Not sure I've used this new blade with vertical cutting yet. Kind of curious to see how easy it pushes. This is the profile I'm starting with. This is the more the critical stuff I'm concerned with. The outside just has to get cleaned up a little close. I should probably go ahead and put a new finer grit on than this old worn out one, but we'll see how this one, oh, excuse me, we'll see how this one does. So, you know, obviously I'm not after perfection here, but it's still a very presentable piece. Once I got to get the mill scale off too, and then wire wheel the edges. Oh, and I still got to drill these holes. And then I should be able to put it down on the template here. See how it looks? This hole's off a little bit. Doesn't matter one bit. There's tons and tons of clearance there. You can see I overground it a little bit too much here. I'm right on the money there, and this is really, really close. So I'm pretty pleased with that. So once I get these holes opened up to 3/8, that'll easily let me check my clearances and stuff like that with the bracket. And these holes, are the X's down there, are just right in the center, right where I want them. Looks like this edge here, that's right on the money. And this one here is not right, but I wavered. I had a big divot in there trying to hand cut it, you know, guide it. And when I flattened that out, rather than coming up with more of a flat spot here, I opted to flatten it out more on this side. So once I radius that, it's off quite a bit. You can see that. Absolutely no effect on what I'm trying to do with it, so I'm not going to worry about it. Like that. What I like is when you have that kind of tolerance and you put it down on the spindle, and all three of them slide right in. That's what I like. This is the first time I'm dropping it on here. So obviously, if it doesn't work, I'm not going to show you. So, usually this is a through hole here, so I usually put that one in just to kind of hold it. You know, that's with all the slop in the threads too. Yeah, that's nice. Now, I'm not going to go in so far that I need a stopper or anything. That'll go right through the middle there. I measured that at 1.23, so as soon as I do a touch-off on there, I'll know where I'm at. I already measured it. I just need to make sure that I'm not behind the face here. So, all I'm going to do basically is, rather than... I need to make one of those bearing things I've seen on a bunch. I think Comp Edge X has used them too. Colin. Anyway, I'm just going to pull it down against these two jaws, snug it, and then tighten it up. And I've got two pads in there of the gripper, more or less, you know. So it should be pretty close. We'll see. Working on this spacer, and I was using that Toyota one. Oh, right there. And I was saying, oh, okay, I could go that short. Well, it dawned on me while I was somewhere else thinking about something. I need this one to be about 80 thousandths longer. I'm not exactly sure how long it is right now. Let's find out. And by long, I mean tall. So this is 482. This is 392 basically. So it's 90 thou difference, which is okay. Basically, I think what I'm going to do is I'm going to set this for ½ an inch. It's going to change this spacer here slightly, but it gives me a nice even number to work with. But anyway, even at 480, what that means is that I still have enough room up here. What I'm getting at is when I do this on the 620, the boss down here at the base of the spindle is 80 thousandths taller. So I need a spacer that's 80 thousandths shorter. Okay, if I did this one as the 521 spacer, it gets me a little more room up here at the cotter pin, but that's as low as I can go and still have room for the seal. Okay, so I wouldn't be able to take another 80 thousandths off that short one. So either kit will still use the stock nut, so I don't have to worry about putting in the short nuts. And maybe this will illustrate it a bit better. And I think I've kind of shown this before when I was figuring out. I may have edited it out, but okay, you can see there that that's really as short as I'm going to want to go. Okay, so I can take 10 thousandths off the other one. They need to be that specific difference though. 80 thou. I'll have to look that up and make sure that's actually the spec. But they do need to be that so that everything squares up with on a 620 spindle. So because Chris, Big Black 620, if he's watching, he's chomping at the bit for a set, and I go to a 620, so I need to, I need to make sure I make it work for a 620. Just a quick shot here. I made the changes in CAD and fabbed up another bracket real quick. It's not quite done yet. The one laying on top, it's just to show the differences, the changes. So, oh, you know, now that I think about it, I changed the tabs, so I have to make new tabs too. And you can see where on each side here I've folded over just a little bit. Everything lines up. You can see here we're rotating. We're not binding up too hard on the strapping here for my spacing. And I did push those in when I put them in and tightened them. Okay, you can hear it scrape there. Right there. Okay, this is with no spacer. That's why I didn't bother to tighten these down. So let's put the 1/8 inch spacer in and see what we got. I should probably put some lube in the bearings so it doesn't sound so bad. Oh yeah. There's close to 1/8 of an inch. There's a nice gap in there. Let's see if we can see it. Basically where we're looking is right there. The part that hangs down is clearing quite nicely. Awesome. Okay, let's double check that the caliper or the bracket has room with the caliper mount. Okay, as one of the guys pointed out on Facebook, Charles maybe, you know, he was talking about how I was trying to be too perfect with the spacing. And he is correct, and I even said that on Facebook, that this spacing here above and below the rotor does not have to be perfect. And so in thinking about that, what I did was I decided to err on having it down that way. That's how I gained some of the spacing. When I put it in this way, I decided to leave it. So anyway, you can look at the top spacing there, and then see the bottom spacing. And you can see how the bottom looks just a little bit wider than the top. So, Charles was absolutely right about that. I decided, I was thinking about it, I'd take advantage of that. I'll see if this angle works, but you can see there's a lot less play there than so. I like that. Now let's now if when they're produced they come out that nice, I'll be tickled pink. Okay, I do have clearance down in here. That's important. When I come down here, I've got clearance over here. And I do have clearance in here. I could probably yeah, even just coming out, there's no real slop there to speak of. Let's whoop. Okay, so this spacing right here, a little on the tight side. I think I'll go into CAD and push that in at least another millimeter. Actually, you know, I might open the radius up a little bit. If I open the radius up, because you can see how it's big here and big here, and when I push this in, it pushes these radiuses in here too. So if I just make this radius bigger, that'll flatten it out and pull the center in without making the outsides go down anymore. That's the thought. We'll see. Oh, so close. So close. I'm not going to make it by this weekend for getting the CAD work in. But it's close. Real close. God, everything else is beautiful. I'm very happy with that. So, time to get off my feet. Oh, man.